Just Dylan and Isabella. Cool. All right, 4.3, solving quadratic equations by factoring. So what we've done so far, we focused on graphing it. How do you solve by graphing? Now we're going to say, algebraically, how would you solve it? Okay, how would you solve it algebraically? The factored form of a quadratic equation is 0 equals a times x minus p times x minus q. This is straight from your book, right? This p and the q, they're the x-intercept, the solutions, the roots, the zeros. Those words are the same thing. X-intercept, solution, root, 0. That way you understand. There's 4 different words. I can ask you to do the same thing. Does this make sense? 4 different words means do the same thing. You set each factor equal to 0. You're solving for the x-intercepts. Okay. So 0 product property. We're going to cover that in a second. So this right here, it's like, how many of you guys took speech and debate class? Speech class? Weren't you required?
In gender you could do debate.
Okay. So it's kind of like when you're in a speech, and the first paragraph is always, I'm going to talk about this thing and this thing and this thing, right? Laying out an agenda and outline for you. So the next 2 days of class, we are going to cover all of these things. And so we're first going to hit greatest common factor. So what are you doing? Can you put your desk down? We're just having problems with you today. Okay. So we solved by graphing, right? We found the solutions by graphing, where they cross the x-intercept. How else can we actually solve them? Okay, algebraically. So first, this is also the order you go through. When you are trying to solve algebraically, the very first thing you do is see if there's any greatest common factor. Can you pull anything out? Only then do you go to the special cases, the perfect square trinomials and the difference of squares. Then, if those don't work, then you go to factoring trinomials, right? The factoring like you have before. And then, only then do you do the quadratic formula. I'm going to be as honest as I can be. On your test, which is the, I believe, 3rd of December. Yeah, December 3rd. You will not have enough time if you solve everything by the quadratic equation. Equation. Right? Negative b plus or minus square root b squared minus 4ac all over 2a, right? That whole thing that you learned in Algebra 1, I think Miss Rotter made you like sing. B plus or minus square root 4b minus Alright, negative b plus or minus square root b squared minus 4ac all over 2a. This is the quadratic formula. Yeah, that's why I put an F. Quadratic formula. What I was saying, if you go straight to this, you will not have enough time to finish your test. I made the test this way. What? Yes. Yeah. You will not have enough time, and I will not give you one. Because I'm telling you the order, right? Like, why would you go and hand wash your clothes in the sink when you have a washing machine, you know? Like, do the easier thing. This is the order you go through. You must try greatest common factor first, because it could be faster. This is the order. You go from the top to the bottom. You do greatest common factor, then you see if you can apply special cases, then you try to factor, and then, only then, once you've tried everything else, then do you do the quadratic formula, okay? This is like very last, like I am out of options. This is option Z. We're done. It's the nuclear option. That's it. This is, yeah. But the majority of them, you will not have to, because it takes a long time. It's a lot of math. Jesse, okay. All right. Do you have to leave early today? No, because, okay. JV's at 3:30. Yeah. Cool. All right. So first, ready? We're going to just like rewind it to Algebra 1. So how do we actually factor? So we're going to use the distributive property. Throw back to chapter 1, which was September, 2 whole months ago. We use the distributive property to multiply a polynomial by a monomial. So I have this 2x, right, a monomial, one number, and I'm multiplying it by a binomial, which is, right, x plus 3 is a binomial, 2 numbers. Okay, and it shows the work there. That's how you distribute. So the reverse, the opposite of distributing is factoring. So the reverse to distributing is you can factor a greatest common number out. So the biggest thing that both of these have in common, they both have a factor of 2 and they both have an x. So if I pull out a 2x from both of them, I'll get 2x times x plus 3. So literally we're doing the opposite of distributing. We're looking for the largest thing in common, largest factor in common. So this, hopefully this should be like a nice little quick question. What is the greatest common factor here, Jesse? Yeah, so both of these are 4. So I pull out a 4 and then I get 4a plus b. Woo, nice. Yeah, let's try out b. I'll give you about 5 seconds. Try out b and then we'll go over it together.
So you put it in distribute.
It's the opposite of distributing, right? When we factor it out.
Oh yeah.
Yep, factoring out, it's kind of like we're putting it into a form where you could distribute it. And the trick is, if you distribute this back, you should get where you started. All right, if you distribute 4 out, you should get back to where you started. Cool. Will you put your computer away? We're working on B. It is C period after this. It is 1:28. And class ends at 2:20. Okay, so here we go. Let's just go down the row. Miranda, what's the greatest common factor that I can pull out of both of these? 9. So since it's divisible by 9, I pull it out and then I'm asking, what times 9 is 9x squared? X squared, and then plus 4, right? So you see how I'm dividing each by 9 because I pulled it out, I factored it out. So if I divide it by the thing I'm factoring out, whatever the answer is, that's what I put there. That's one way to think about it. All right, Dylan, you're up. Well, I'm going down the row. There's a pattern. I go Jesse, then Miranda, then you.
I don't know.
Huh?
So you sleep it?
Yeah, this is it. I factored it out. I'm done factoring. Notice that x squared and 4 have nothing else in common.
So it's 4.
So all of these are divisible by 4. What else they have in common? R. They all have 4r in common. Mm-hmm. So okay, so I'm looking for what times 4r is 4r squared. Yeah, it's just r.
Plus
2 s
plus 7.
Exactly. Okay, so look, there's nothing else in common inside here, right? 7 and r and 2s, nothing else in common. But they all have an r in there, and they all are multiples of 4. So I pulled out the greatest common factor. What? Are you guys texting?
What?
I don't know. These guys are just looking at each other weird. Okay. I'm done. Level done. Okay. Do I have a D? Perfect. So, look at D. Think how you could do it. Think to yourself, what's the greatest common factor? Give out 5 more seconds. Turn to the person next to you. Turn to the person next to you. Turn to the person next to you and discuss. What do you think?
6.
Sorry. Did you have time to write this down? Huh? Do you guys have time to write this down?
Yeah.
6xy.
All right. Dylan says 6xy. So they all, let's see, the greatest common factor all of them have is 6. What's wrong if I pick 12?
Wait. What?
12 can't go
It's
under
not
30. No, you can take away the x1 with the...
So if I pick 12 as my greatest common factor, 12 goes into 12, 12 goes into 24, but it doesn't go into 30.
It's just nothing, right? It's just 2.
2. Yeah, because the x's cancel out, the y's cancel out, and 12 over 6 is 2.
Plus 4 squared.
Plus 4y. Maybe I should do this in different color. Oh no. So I'm trying to show you how these cancel out. The x cancels out the y, and then 12 over 6 is 2. Right? The x's cancel out. One of the y's do, and I'm left with a 1 on top, 1y. 24 over 6 is 4, so I have 4y. And then lastly, let's see. One of the x's cancel. Only one of the y's cancel. And then 30 divided by 6 is going to be 5.
5xy to the third.
So it'd be minus 5xy to the third. So it's a little bit harder, but you know what? It's doable, right? You guys can do it. Yes. I know you're going to ask that. Look, okay, this is you. Here, and then you're here, and then you're looking down, and then you're here, and then you look at Dylan, and you're laughing. Okay, go fast.
Sloppy.
You see what I'm talking about? It's really, like, once your attention here. Okay. Okay, let me pause. Questions so far?
Oh,
Yes. Let's go Ruby, then Ashton.
I'm just
Can you what?
just give you
Give it to me in the class. Not right now. I'm trying to teach a lesson. Okay, Ashton. You say beep beep? Wait till after he goes. He's when he gets back, he can go to the bathroom. Okay. Factor by grouping. So the next part is factor by grouping. So we also are using greatest common factor, but what if you have something like with lots and lots of terms? It's not so easy because maybe not all of them have something in common, but some of them do. So when you factor by grouping, you're using the distributive property to factor polynomials having 4 or more terms. So the important thing is 4 or more terms. Pairs of terms are grouped together and factored. And then the distributive property is then applied. So remember, we're using the distributive property. It's just we're not actually distributing. We're doing the opposite, right? We're still using distributive property, but it's the opposite way, I guess. Instead of distributing it out, we're pulling it back. So we're using distributive property to apply a second time to factor a common binomial factor. Okay, so what the heck does this even look like? So I look at these first two, right? And I say, what is the greatest common factor? What does both of these have in common? And I will say 4b. They both have 4b as a factor. If I take 4ab and divide by 4b, all I'm left with is a. 4b times a. And 8b divided by 4b is going to be 2.
So it's the same thing?
It's the same thing, it's just a little different. Now I look at the second 2. What's the greatest common factor they have in common?
Oh, so we're grouping.
Yep, so we're just we're grouping 2 together, grouping 2 together. How do I know?
Where to group it?
You do the 2, and then the next 2. I'm not gonna give you 5. I mean, you could, but yeah, you could have a trinomial. A trinomial has 3 numbers, 3 noms. Try 3 nomial. You can make a trinomial. What? You're saying? Don't apologize. Apologize for your groaning earlier. That's what I need. Ashton, sit up. All right. What? Almost. So, okay. Ready? Imagine I had 4bx plus 3x. Notice that they still have a common factor. What if I would pull out this common factor of a plus 2?
You can do FOIL.
Wait, what? Oh, that makes sense.
You can FOIL, right?
Notice I have a common factor between the 2 terms. Oh my gosh. Then factor by grouping doesn't. You could leave it then. But if I'm gonna give you a factor by grouping problem, this would work out. And if I'm being honest with you, this is probably the one I struggled with the most because it's not super clear always. What the heck is going on here?
I don't like graphing.
Is this graphing a
No.
no? Then no. Okay.
I don't like this.
Cool. I acknowledge your opinion and your feelings. I acknowledge your feeling. Okay. Acknowledge you. Okay.
Do we leave it?
This is it. I'm done. So
Can we do the next one?
I'm done. I got this fully factored.
Or you just grouping them together?
Yeah, I grouped them together. That's why it's called factor by grouping. Okay. That's exactly the look my brother gives me. He's always judging me. He is. Earlier, I was like, Dylan, literally the looks you give me are the looks my younger brother give me. Where he's not impressed or annoyed. Those are the looks my brother gives me. But it is what it is. Okay, so let's try factor by grouping. So I'm looking at the first 2. What is the greatest common
5y.
factor? What's the biggest thing I can pull out? 5y. What? Hello. Just wait.
No points.
Okay, I shouldn't have to ask you more than one time. All right, go ahead. Put your phones away, like it says on the board.
I didn't know.
Jesse, is your phone over there?
Yeah.
Good. Make sure you missed the memo. Okay, here we go. You know what this is called? Trust broken. That's what this is. Trust broken. Goodbye. All right. 5y squared minus 15y. So the biggest common factor, right? Greatest common factor is 5y. Pull that out, and I will get y minus 3.
Why not just 5y?
Let's see. So 5, one of the y's, so I'm left with y. 15 over 5 is 3. The y's cancel out. Oh, yeah, I forgot. I started screencast and I froze this. My bad. Here you go.
Oh, sorry.
And then, let's see, greatest common factor is 4, so I'm going to 4, and then this is y minus 3. And notice we have a common term of y minus 3, so I pull that out, and what I'm left with is 5y plus 4. Okay, let me pause here. Try out B, but do we have questions over this? Yes, Ruby, no? Literally, class started 14 minutes ago, and there's
18.
3. No, it starts at 15.
Yeah, it's 40.
That's not 18.
It's 22.
I'm looking at 39. 24. No, I don't know.
You're the math.
24 minutes. Really? I don't see you guys drinking liters and liters of water. Whatever. Bathroom pass is bathroom pass. Good.
20, 40,
All right. Did you try B yet? Bombs. You guys are bombs. Leaving class all the time. Okay. Okay. That's fine. I know. I shouldn't call you bombs. Just want you to be here. Okay. Let's try the next one. What's the greatest common factor? These first two. 5c. This is literally going to be 1 minus 2c. Who did I leave off on? Ugh, I left off on Ruby. Huh? What's 5c over 5c?
1.
1. Right? If I pull out 5c times what is 5c? 1. Then I have, let's see, 2d is the greatest common factor. So I pull out 2d and I'm left with 1 minus 2c. Notice 1 minus 2c is a common factor.
So whatever the first number is, you divide it by the rest.
No, not necessarily. It's just because this was the greatest common factor. Notice a, we didn't do that. A was 5y squared. I divide by 5y. I'm looking for the greatest common factor.
So
This
whatever the greatest common factor is going to be
Yeah.
on the outside.
Yep. Exactly. Try out C if you have not done so already. Just a moment. I'm writing this down. Okay. So, here we go. Greatest common factor between 10x squared and 14. 2x. Because there's no y in the first term. So, if I pull out a 2x, I'm left with 5x and minus 7y. Yes or no?
Yes.
Right, the y cancels out. I'm sorry, the x cancels out. It's 14 over 2 is 7y. Right, so one of the x's would cancel out the top here, and then 10 over 2 is 5, so 5x. All right, greatest in common, let's see. Pull out a 3, so I'll say plus 3, let's see, so pull out 3, so this is negative 5x plus 7y. Because notice this was negative 15. Ooh. Right. So what we notice, so I'm about to answer. So what notice, on the left, 5x is positive. On the right, 5x is negative. Ooh, opposite. On the left, 7y is negative. On the right, 7y is positive. Literally are different signs. What if I factored out a negative 1? Right? If I pull out a negative 1 from here, pull out a negative 1, so that way it's negative 3 instead. It flips this to 5x minus 7y. So if I pull out a negative 1, it changes all these signs. What's negative 1 times 3? Negative 3. Now they match because my factors were exactly opposite, right? I had a positive 5x on the left and a negative in the blue on the right.
Why isn't
I need it to match exactly. So to match exactly, I had to pull out a negative 1.
Why isn't it 2xy though?
Where? Because there's no y in this term.
But also for the in the parentheses, it's also like that. There's only one line.
Yeah, because it comes from this guy right here. Hold on. Goes there. This y comes from here. This is where the y's came from, where those terms. Okay, and then, of course, you see 5x minus 7y is in common. So I pulled that out and left with 2x minus 3. Whew. All right. Questions about this page before we go on? Okay, I think you'll like this next one because it's a little easier. A little easier. Okay, zero product property. For any real numbers a and b, if you multiply two numbers together and it's equal to 0, then either a is 0 or b is 0. Okay. So it's kind of like have you guys ever been to like Venice Boardwalk or like maybe Santa Monica or something? There's always these street performers and sometimes there's these magicians. And they're like, guess what's in my hand? And like, I don't know. I have no idea what's in your hand. But if I tell you, I'm holding two numbers, I'm thinking of two numbers, when I multiply them, it's equal to 0, you're like, I know at least one of those numbers has to be 0. Because anything times 0 is 0. That's what the zero product property is. It's like I have two numbers, you don't know what they are, but when I multiply them, it's 0. You know one of them has to be 0. So imagine if I took one of my solutions, one of my x-intercepts, right? It's a root, it's a solution. One of those zeros, and I put it in for x, it should give me a y value of 0. So the zero product property is how we actually find the roots algebraically. So what you do is you fully factor it, right? You fully factor it out, whether it's by grouping or anything else, and you set each of the terms equal to 0. So for this first one, I know that if x minus 2 times x plus 1 is 0, then, let's see, if I set x minus 2 equal to 0, add 2, I know x can equal 2, or the other one, right, set x plus 1 equal to 0, minus 1 on both sides, or x could equal negative 1. Those would be your two solutions, your two zeros, your two roots. Yeah? Nah? Maybe? Okay. Yeah. Okay, solve each equation. Literally what we're doing, take each factor, set equal to 0. So notice I have two factors. So I set the first one equal to 0. Oh my god, why is it not writing? So I set the first one equal to 0, h equals 0, oh, literally I'm done, I'm good. And then I set the other one equal to 0, h plus 5 equals 0. To get h by itself, I have to subtract 5 on both sides. So you say h equals negative 5. So the two solutions would be 0 and negative 5.
That's it?
No, it doesn't matter. You can say negative 5 or 0. Because you're just telling me the answers, right? You're just writing. What? And? Oh, yeah, that's what that little squiggly is.
No.
Means what? And.
Always and?
Yeah. Because I want the solutions. I want you're solving. So there are multiple solutions. Okay, because it means like you could have either one works. Yeah. So only one of them You only, okay. So I have two numbers, right? One of them has to be 0. So either the one on the left is 0 or the one on the right. Well, guess what? There's actually going to be two numbers that make it equal to 0. That's why you take each one and set it equal to 0. Well, guess what? My solutions are all the x's that make it go to 0. So my solutions are going to be 0 and -5, because that's why I set each of the factors equal to 0, because like if I plug in 0, this middle one, 0 plus 5 is 5, right?
Yeah.
But then you still, so you get 0 times 5. Oh, that's still 0. Only one of the factors have to equal 0. What if I insert -5? So -5 times -5 plus 5. Oh, then I literally get -5 times 0. At least only one of your factors has to go to 0. Okay, tell you. I was gonna wait till Ashton gets back. Yeah, it's fine. You can go. Whatever. Okay, try out the next one. Try out the next one. What, you're setting each factor equal to 0?
Oh, I meant.
No. Try out B. Try out
I
B.
did it already.
Yeah?
Mhm.
Okay. Yeah. Let me write down the bathroom pass. Okay, so B, you said each factor equal to 0, so you'll have n minus 4 equals 0. Why is this not writing? N minus 4 equals 0. So add 4 to both sides, you see n equals 4. Also, n plus 2 equals 0. Subtract 2 from both sides, you see n equals -2. So n equals 4 and -2. Because when I say n equals 4 and -2, I'm literally just wanting the solutions. I'm wanting the zeros. Okay, so for this next one, it's not equal to 0. So I need to get everything on the same side, so it is equal to 0. So I'm going to subtract 7x from both sides. So x squared minus 7x equals 0. I need to factor this. So before, what I had was factors, things being multiplied. This is being added and subtracted. So can I factor anything out? X. Let me pull out an x. So I have x times x minus 7.
Is this what we did before?
Now it's exactly the same form as A. Do you notice C looks just like the beginning of A? Yeah.
And then from there
And then we just set each factor equal to 0. We set each one equal to 0. So I have x equals 0. So x equals 0 and 7. All right, if you're done, try out D. This is kind of the way it's going. Right, and if you finish D, try out E and F. All right, some good practice. So once again, we have to have it equal to 0, so I'm going to move it to the other side. The greatest common factor is m. I can pull out an m, then I'm left with 3m minus 5. Set each of these equal to 0.
You wouldn't use 5m.
Huh? I pulled out an m. What is 5m divided by m? Just 5. Do you want me to pick another color and to show you? Yeah. So the greatest common factor is m. So if I pull out an m, oh my gosh, come on, right. Pull out an m from both of these. Because that's why I'm factoring out is an m. One of the m's disappears for the 3, and then the m totally disappears for the 5. That's why it turns into 3m minus 5. Cool. Okay. So add 5 on both sides, so I have 3m equals 5. So m equals 5/3. So it's a fraction, but like it's doable because it's just at the end. So this little symbol in the middle means and. Like I'm just writing all of my solutions and boxing them. I'm trying to like help you guys so you'll box your answers on your homework. That way if it's correct, I don't have to like look through all your steps. But if it's not correct, I do look through your steps to give you as much credit as possible.
Wait, why did you just make m 0?
You set each factor equal to 0. So the m is being multiplied by 3n minus 5. So I set m equal to 0, and then you set 3n minus 5 equal to 0.
Oh, okay.
What you do to one thing does
It's a
to
much
everything.
nicer number when I did it.
Yeah. So notice, we had to get everything on the same side. You had to get it on the same side, then factor it out. Okay, let's try it out. If you haven't already, I think you can do E. Yeah. Greatest common factor, 3y. What do you mean? Know the biggest common factor?
No, I did it, but I don't know if I did it right.
Oh.
You just did 2y minus 1.
2y minus 1?
Wait.
So you set 3y equal to 0, divide by 3. You get y is equal to 0.
So
2y minus 1 equals 0. And then it's just a two-step algebra equation. All right, how are we feeling about this? Yep. Yeah, it's all cool. Question? No? Okay. Okay. So I'm going to move to get everything on the same side. 0 equals 25w squared minus 5w. The greatest common factor. For which one? The one we're doing? I don't know. I'm doing it right now. 5w minus 1. Okay. All right, did you guys finish E and F? Yeah, sorry. Okay, I think you guys get it, so we'll skip G and H. So I think we're okay. Let's see if you have questions. We got 10 more seconds to write this down.
Are we supposed to finish the lesson?
2 days for this lesson. Okay. No, I knew this is too much for one day. I want to give you guys plenty of examples and like, no, I'm just letting people like finish writing. Shh. I'm trying to be patient. Yep. Sometimes when I have a lot of tea, I tend to like start rushing, so. 'Cause tea has caffeine. Okay, so before I go into the special stuff, okay, so up here, remember the order that we're going to actually go through stuff? So we learned, okay, as soon as it loads, we learned greatest common factor. How do you factor using greatest common factor, right? So we did that. Before we go through the special cases, we're going to talk about how you even factor trinomials. And then hopefully it'll make more sense when we talk about like perfect square trinomials and difference of two squares. So 100%, you have learned this before, but it's also fine if you don't remember it because we're covering it again. All right, so we're trying to make sure everyone is solid. So first, let's go back and we're going to solve trinomials. We're at the top of page 25. Solving trinomials. And keep in mind, things are in the order x squared plus bx plus c. Notice, what is the a? What is the coefficient from x squared? 1. We're dealing with quadratics with a coefficient of 1 in front. Now, if I have a coefficient other than 1 in front of x squared, it's a little bit different. So first, what we're going to focus on is just having x squared plus something x plus some other number, right? So these two things, we're going to have a coefficient a in front of x be 1. Okay, so to factor trinomials of the form x squared plus bx plus c, find two integers, m and n, with a sum they add to b, and then they will multiply to c. All right, so you're thinking of two numbers that add to the middle and multiply to the outer. Okay, so, yeah, this is just the thinking of two numbers that add to the middle and multiply to the end. For example, blah, blah, blah. Okay, whatever, let's do this. So, factor is trinomial. We have x squared plus 6x plus 8. So, we're looking at the middle, right? What factors to 8, so what multiplies to 8, but sums to the middle, which is 6. All right, let's think. What are the factors of 8? 1 and 8, 2 and 4. And then the sum. What are the sum of these? 9, sum of 2 and 4 is 6. We're wanting the ones that multiply to 8, 2 and 4, and then add to 6. So we're going to use these. These will be our two numbers. So you have x plus 2 and x plus 4. What? So the sum is to the middle number b, and the factors, what they multiply to, is to your c. Remember, it is ax squared plus bx plus c.
What happens if you can't find it?
That's a good question. If you can't find it and no numbers multiply to 8 and add to 6 in our case, that's when you would have to pull out the quadratic formula. That is when. Like when there are no possible integer values that you could plug in, that's when you have to pull out the quadratic, because that's when you're going to have like some decimal or something. Good question. Okay, should we try the next one? Energy. Energy. Okay, so what is going to multiply to 4? Okay, factors of 4. 1 and
3.
4. What? Sorry. What multiplies to 4? What? What?
Keep it in that form.
Yeah, this is it. This is the factored form. I'm good. What? What multiplies to 4? 1 and 4 multiply. What? I'll rewind the screencast. I did. It's okay. I
2 and 2.
2 and 2. Okay, 2 and 2. All right, let's see what they add to.
First one.
Wow. Okay, we're summing to 5, right? So it adds to 5, multiplies to 4. So we're looking, what adds to 5, it's got to be the first one. So we have x plus 1 and x plus 4. How are you feeling so far? Hey,
That's all you do.
that's good. That's good.
More.
Huh? Yeah, we're going to have plenty more examples. Look at this whole
All we're
page.
doing?
No?
No, like, you don't,
Oh, for this example, no, it just wants us to factor, and we factored them.
but like, for these problems, are we gonna have them?
Yeah, so I'll give you a quadratic. So like ideally we'll get to the point where I give you a quadratic, it's set equal to 0, you factor, and then you set each of those factors equal to 0. So like,
All of this and-
yeah, so that would eventually be, I'm just trying to like little pieces at a time, and then we'll put it all together for a nice picture at the end. Okay. So we're looking for what adds to the middle, adds to 2, and multiplies to negative 15. So it needs to be factors of negative 15. What are the factors of negative 15? I could have 1 and negative 15. I could have negative 1 and positive 15. What else?
Wait,
Because, ready? Negative 1 and 15 is multiplied to negative 15, and negative 15 and 1 multiplied to negative 15. What? What? Look, multiply to negative 15. There's a negative in front of it. Okay, 3 and 5, right? Negative 3 and 5 or negative 5 and 3? Negative 3 and 5 and 3 and negative. Yeah, there's a better way to do this. This, of course, is okay. What do they sum to? So this sums to negative 14. This sums to 14. This sums to 2. This is negative 2. What we're looking for is positive 2. So I have x minus 3. Oh, I'm sorry, it's a. Ugh, I wasn't even looking at my variable. A minus 3 and a plus 5. Okay. Trying to trick you on D. What did I do on D? Yeah, I didn't put it in the right order, so rewrite it. What?
I swear you did this in my algebra.
Correct. Correct.
So can you do it the other way?
What other way?
Where like
The X method?
you just do like for
What?
C, you would just do like what multiplied
Literally what I've been
15
verbally
but
saying.
equals to
Like what I'm verbally saying?
about that.
Yeah, of course. We're not always gonna have the whatever I'm doing on the right side. Trying to jog your memory and help you see what's gonna add and sum. Okay, so I gotta rewrite this in the correct order. T squared plus 10t plus 9. That way I see this is what I multiply to. This is what I add to. So adds to 10. 1 and 9, 3 and 3, add it. Okay, I want you to try out, how many do we have left? Like 4? 1, 2. Try out the next 2. Try out the next 2. Yeah, sorry. I know I was fast. Try out E and F. Try them out. Practice, practice. So give out E and F a shot when you're done writing this. Let's see. Ashton, are you trying it out?
Mm-hmm.
Okay, you're gonna take your hood off. Thank you. So let's move up a little bit. So notice.
I finished.
Finish.
Oh,
I was fast.
No, me first.
You didn't write it.
Well, that's just to prove how much better I am than you.
I wrote it.
Well, see, you had to write it.
what is going on?
That's what
Cut this nonsense.
No,
Cut this
but
nonsense. What is
words
this?
that I don't need to write it.
Oh my gosh, please stop. I separated you across the room.
You have to write it.
Dylan, Ashton. Oh my goodness. You just like no, I separated you across the room. This is over.
You know, it's just we're joking with each other.
You're wasting my time. You're wasting my time. You're wasting my time. I need you to write.
Me and Dylan are joking.
Imagine you could get 100 on your test. Oh no, because you're wasting my time with this nonsense. My God. Okay, so tricky trick. Notice negative 10. What's gonna add to negative 10? Ooh, tricky trick. Okay. Did you guys get a chance to try this already? So whenever you're adding to a negative, at least one of them has to be negative. But wait, we're multiplying to a positive number.
Jokes, negative.
So that means both numbers have to be negative. Okay. So because they're adding to a negative but multiplying to a positive, both numbers have to be negative. So I can have negative 1 and negative 16, or I can have negative 4 and negative 4. We want them to, oh, I also forgot negative 2 and 8. All right, add them up. So this is negative 8, negative 10, negative 17. We want them to add to negative 10, so it's going to be this last one. Because if you think about it, if you multiply a negative times negative, it's positive. So this is always the trick play. If you have a negative in the middle and a positive at the end, you know both numbers are going to be negative. Okay. So x minus 2 and x minus 8. All right, let's try the next one now that we know that. What? Oh, okay, yeah, let's go. Let's do it.
-7. -4.
What? No, come on. Okay, add to negative 11. Multiply to 28. Okay, so it multiplies. Okay. Negative 1 and negative 28. Negative 4 and negative 7. They add to negative 11, negative 29. You say this is the 1. So we have s minus 4 and s minus 7. Wonderful. Okay, how are we feeling on this so far? Like,
Good.
yeah?
Better. Yeah.
Okay,
Ask.
maybe? No? Okay, cool. It's fine.
No.
Literally, I looked at you and you're just like,
No.
like your eyebrows clenched. Oh, okay. Okay. Ooh, this is a good one. Let's do G. What? I'm gonna ask everyone. I'm going around the room. Okay. What? It's fine. So on your, like on a test, I'm expecting some form of work. If it's not this like little T-chart thing, I'll show you what I do. Okay. So for me, I always do this little X. I don't know. Maybe this is banned here at D Toledo.
I learned the X and it
What X?
messed me up.
What is this X I just drew? Do you not see it? Look, X.
What
Okay.
is it
What?
for?
It's just another way.
So it's another way to think about it.
Real confusing.
I'm looking for what adds to 3 and multiplies to negative 18.
I'm getting flashbacks.
So because the X means you're multiplying. Yeah. So what multiplies to negative 18 adds to 3? 6 and negative 3. 6
Yep.
and negative 3. Cool. So I have X plus 6 and X minus 3. Okay, that was kind of fast. We can go through and show we did it the same on the right side, but this little X, that shows work.
I like
The X? Yeah, I mean, that's the way I learned it, but also my Algebra 2 teacher was no bueno, and I'll be first one to tell you that.
It's very confusing.
Yeah.
I like the
So, right, so this is great. Ready? I'm giving you options. I'm giving you options.
I agree with everyone. Please
Done.
don't
Ruby. Okay, so there's 2 ways. If this X makes sense, coolio, awesome. Otherwise, you could use this little T. That's what they use in. Yeah.
Oh, wait, it's negative 3.
What?
Just say yourself. What multiplies to negative 18 but adds?
That is what I've literally been saying.
No.
So you said that you have to share your word.
Yeah.
I feel like you
So what if I just wrote that, like the X plus 6?
Make up some word. Yeah. Imagine you accidentally put the wrong sign. What if you put like X plus 6, X plus 3? Ooh, I don't know. Ooh.
X plus 3 minus.
What if you accidentally put a plus here? That's
I would
wrong.
know, though.
Oh my
Then it's my
god.
fault. Then like I get it wrong.
Okay. Okay. Factors of 18. Ah, okay, fine. Okay, so if you don't like this X method, that's fine. If it works for you, it works, right? This is literally what I do in my head. I'm like, okay, what adds to this, multiplies that, and I like try a couple different ones. Cool. Okay, so factors of 18. So one of them have to be negative, the other has to be positive, because they multiply to a negative number. So that's why one of them have to be positive, one of them have to be negative. Negative 3, negative 6, or negative 3, comma 6. And when I add them, negative 3, 3,
No,
negative 17.
Don't.
What?
Don't.
I just want to see something. I want to see something on your paper. That was really vague. I want to see something that is pertinent to, like, you know, pertains to what how you're solving it, not just like anything. You can't just draw a picture.
Can you do a table and
Sure.
2 numbers that work?
This table,
No other
perfect,
numbers?
perfect.
Okay, that's what-
Look at this, wonderful. Okay. Do we need another example? No. Okay. So. Huh? Okay. You know what? Let's do this last one, and then we can end.
Oh, I know it.
Okay.
Oh shoot. Yeah.
Yeah. Okay.
Say
Sure. Go ahead. Yeah.
X minus 5.
How did you find this? Because if I have negative 5 and 4, they add to negative 1.
Which is X.
Right? Because you literally could do this. Negative 5 times 4 equals negative 20, and you could do negative 5 plus 4 equals negative 1. This right here, what I showed, shows work. That's chill. That's great. What now? You two need to be separated for real. I know.
I'm telling you.
You know what? You know what? Let's go do.
No.
I can't have you sit by Ashton. I can't have you sit by Ruby. Common. Okay.
I don't know why you put me next to Ash.
Okay.
He's joking.
So let me make sure. Hold on. We have 7 more minutes. 1, 2, 3, 4.